Hidely ho there, neighborito. Nay, my name is SparkYo, your bad boy of electronics engineering, and welcome to the only good NES recap video on the entire internet. And by recap video, I don't mean that we're going to have an informative retrospective about the history of this legendary gaming console. No, none of that. I mean that we're going to remove the capacitors and put in new ones. You see, cap is what geniuses like me call capacitors, so deal with it.
Hey, I don't like your attitude.
I don't care. So why would anybody do this? Well, you have to do this if you're having video problems like wavy lines. You also need to do this if your audio is getting quiet or weird, and you definitely need to do this if you've had any problem that got better when you replaced your high-quality Japanese power supply with a $12 piece of crap from Amazon. Why is this case so big? I would also highly recommend recapping your NES if it's between, say, roughly 27 to 37 years old. Capacitors don't last forever, they eventually go bad. Also, if you happen to have a Famicom that was built after Y2K, hit me up. I want it. Now I know what you're thinking. This whole NES recap thing sounds pretty magical. What can't it do? Well, if all your Nintendo does is sit there and blink a red light on and off, the first thing you need to do is find this chip right here, number 3193A, and count up to pin number 4 from this circle, right there on the bottom. Then you just sort of need to make that pin go away forever. Then your NES will be physically incapable of making its light blink. Problem solved. You would also need to clean or replace the connector that would be roughly here, had I not thrown that part away when I was in college. This Nintendo is a Windows XP computer. Pay attention! If your Nintendo doesn't power up or show anything at all, even with a new crappy Amazon Power Brick, then you still need to recap your NES, and you'll also have to replace this screwed up weirdo right here, Mr. 7805. We'll talk about him later. Let's do this. Now, I've already saved us a lot of time because I've already desoldered this RF modulator box. There's 4 really big pegs and a line of heavy pins right here. If all you have for desoldering is one of these little solder suckers, then give up now, it's hopeless. You're gonna need a better solder sucker. I have this Engineer SS02 made in Japan. It's very useful because it's got a little silicone tip that you can kind of embed in the pool of solder. You're also going to need a lot of solder wick and a lot of time. It's a really big hassle, but there is a better way. If you don't have a good solder remover, then once you get rid of this big capacitor right here, most of what you need you can access through this hole in the shielding. It's finicky, but it's better than removing this whole thing. Now, if you find yourself desoldering things regularly, I recommend you get yourself a real desoldering tool like this Hakko FR301. It's expensive, it's a power tool, and this just makes the solder go away. If you value your time like I value my time, then it's worth it. If you don't do a lot of soldering or if you can't afford it, totally understandable. But you'll know when you need it, and it's something to think about. Okay, back to the RF module. You've got 1, 2, 3, 4 points to desolder, plus this strip of connections, and then 2 pieces of metal shielding. You can also desolder the headers from the other side. It might be easier. Okay, let's set aside that main board. Pull off the shielding. Wow. All of these RF boxes do the same thing, but they're not all built the same way, so don't be surprised if there's some differences, especially if you're in Europe, for example. Both of the boards I have right now are made by Alps. They had different models of capacitor, but there's the same number and they were spec'd to the same values. We have 6 different capacitors in this box. We're going to pull out each one, call out the values, test them to see if they were bad, and replace them. If you can't get this whole box off, you're going to miss this capacitor over here in the corner, which is for the RF output, which is like your TV antenna. It looks terrible. It probably doesn't work with your TV, so who cares? First things first, let's start with the big one. We have a Nichicon VTM rated to 105 degrees Celsius, 2200 microfarads, 25 volts. Give it a test. Okay, we've got 2260 microfarads, V-loss of 1.5%, and an ESR of 0.12. So this capacitor was good. We're going to replace it with a Rubycon YXJ 25 volt, 2200 microfarads. By the way, I'm going to put all of these parts in the video description, maybe even a cart for Mauser or DigiKey. So if you're following along, you can just buy that. But if those parts are out of stock, or if you need help finding an alternate, go ahead and leave a comment, I'll help you out. All right, the replacement is 2166 microfarads, V-loss of 0.9%, ESR of 0.09 ohm. V-loss and ESR are bad, by the way. These numbers go up as the capacitor wears out, and you want them to be as low as possible. Okay, the second one out is this stubby little guy, 10 volt, 100 microfarads. If you actually are having video out problems, this guy could be to blame. For me personally, this is preventative maintenance, so all of these capacitors are probably fine. 102.3 microfarads, VLOS 1.2%, ESR 1.4 ohm. It's probably not performing as well as it used to, but it's fine. We're replacing it with a KMET ESL 100 microfarad, 35 volts. I don't want to pull this box off again, so I bought these for long service life and high reliability. The new one is 92.56, VLOS 0.7%, ESR 0.27 ohm. The next up is a taller one. It's a Nichicon VTM, 105 degrees Celsius, 100 microfarads, 25 volts. 109.4 microfarad, VLOS 2%, ESR 1.1 ohm. The replacement again is a KMET ESL 100 microfarads, 35 volts. If you're wondering why the voltage is higher, you can pretty much always go up in voltage on a capacitor, but when you go up in voltage, the capacitors tend to get bigger, and we're pretty space constrained, so when you're ordering the capacitors, make sure they'll fit in this little box. You've got about 11 millimeters of height to work with. Next up, C29, 1040 nanofarads, which is pretty much 1 microfarad, so that's good. VLOS 0.6, ESR 7.1. That's higher than I want it to be, but it's still fine. So these 1 microfarad capacitors, we're not going to replace with another electrolytic capacitor. What I have is a WEMA polyfoam capacitor rated at 1 microfarad, 63 volts. These cost more, but they're never going to break open or leak like an electrolytic capacitor can, which is the exact problem that I'm trying to avoid. So to me, it's worth the extra 20 cents. Next up is C35. It's the same as the last one. 50 volt, 1 microfarad, 1066 nanofarad, VLOS 0.7, ESR 5.8 ohms. Finally, we have the sneaky guy in the corner. It's the exact same size as the 1 microfarad 50 volts, but this one is 10 microfarads 16 volts. So pay attention. You've got 10.36 microfarad, VLOS 1.8%, ESR 3 ohms. I'm replacing it with a Nichicon LDM 10 microfarad 50 volts. Now let's just solder those down. There's a white marking on the board for the negative side of the capacitor. There we go. We've got all the capacitors in the RF board. Now, if you're really fixing a problem, and after you've gone through all the effort to open this thing up, you probably want to also replace diodes D1 through D4. Diodes are cheap, they're not hard to replace. I don't know the part number of the originals, but anything that can rectify 1 amp at 9 volts will work. The 1N4001 will do this, but if you're going to buy those, go ahead and get a 1N4007 and just buy a bunch, get a bulk discount. They're a very useful common thing. I wouldn't worry too much about getting exactly what's there, just get something that will get the job done. As preventative maintenance, I don't need to replace these. I already know they're good, but you might not have 4 rectifier diodes. You might have a bridge rectifier instead, one of these guys. You can replace it with an RC207, which is rated for 2 amps at 1000 volts. Okay, let's snap this back together and move on from the RF modulator. We've got 3 more electrolytic capacitors on the main board. All 3 of these are made by Rubycon and they're rated at 85 degrees Celsius. All right, first up, we've got 1 microfarad at 50 volts, C23. It's rating 940.2 nanofarads, 0.2% VLOS, ESR 1.6 ohm. We're replacing with a film capacitor by WEMA, 1 microfarad, 63 volts, coming in at 934.6 nanofarad, ESR 0.06 ohms. Next, we have C9, rated at 2.2 microfarads at 50 volts. Coming in at 2000 nanofarads, or 2.0 microfarads, VLOS 0.4%, ESR 2.2. This one we are also replacing with a WEMA capacitor, 2.2 microfarads at 50 volts, which reads as 2226 nanofarads, ESR of 0.0. It's worth pointing out that this tester is not that accurate. Last up, we have C1, rated to 100 microfarads at 6.3 volts. Coming in at 95.38 microfarads, VLOS of 4.7%, ESR 0.92 ohms. And replacing it with our third KMET ESL 100 microfarads at 35 volts. And make sure you get the polarity right. There you go. All right, and that's it for the capacitors. These are all good parts, so hopefully this lasts for another 35 years. Now, the very last thing we're going to do is to replace the 5-volt regulator, which on this board is an HA17805, which is a variant of the 7805. So the first thing you do is to pull off this heatsink by unscrewing it. So it's a simple device with 3 pins. So because of those diodes and its big capacitor, the 9 volts AC coming into the wall will be 9 volts DC by the time it reaches this regulator. That's why the cheap Amazon power supplies solve problems with bad capacitors and bad diodes, by the way, because those output 9 volt DC, which just sort of bypasses all the circuitry meant to convert AC to DC. So I'm going to replace the HA17805 with an MC7805 ACT. You don't need to do this as preventative maintenance. You only need to do this if you turn on the power and nothing happens, no LED, no anything. Okay, we've got the new one in. Make sure it's straight and lined up with the screw hole. A modern 7805 should perform better than the HA17805. They should be more efficient, the voltage should be more stable. This one in particular has ESD protection, or protection from static electricity. The old one does not, but for the most part, it really doesn't matter. Okay, let's screw that back on. And if you have a little bit of thermal compound, like for your computer, make sure there's some between the heatsink and the transistor. Now, if this new part were actually more efficient, it should put off less heat. So let's go find out. Well, those results speak for themselves, so not really worth it. Don't forget to solder the RF and power supply board back onto the main board good and tight. And that's really all I have. If you enjoyed it, give me a like. If you hated it, give me a thumbs down. Please consider subscribing, and I'll see you next time. Okay, bye.